So we were given this diagram right here and asked to determine if point A or point B had the higher voltage, and then to determine the difference in voltage between the 2 points. So we started by drawing some loops in our circuit. The green represents our internal loop and the red represents our external. These arrows are showing where we think the current is flowing at each of these different resistors. And then here, just to make it more cohesive, we went ahead and made the resistors, put them in parallel to each other, and we did that by combining these two series, the 10 and the 5 resistors, and these two, the 4 and the 6 resistors. And because they are in series, all we had to do was add them up. So at point A, it would be 15 ohms and 10 ohms at point B. We went ahead and redrew our loops. So the internal and the external, the 10 ohm is where our B current is, the 15 ohms is where I current is, and over here at the 3 ohms you have our third current. So then we went ahead and started building our equations for our loops. So the first equation is for our outer loop, where you had the 15 ohms times your A current plus the 3 ohms times your third current, and can't forget the 9 volts that we started with. And then our second equation here came from our internal loop, where you have the 9 volts plus your 10 ohms times your B current and your 3 ohms times your third current. And then just the way we drew our arrows, we got that the third current is going to be equal to currents A and B added together, because this would be where it would branch off into these two currents. So from there, I went ahead and reorganized equation 2. Sorry, I messed up on the colors. I went ahead and reorganized equation 2 so that it is in terms of I3, current 3. And from there, I put equation 3 and equation 4 are both in terms of current 3. So I went ahead here and set them equal to each other. And from there, I just solved for what the next equation would be, which I called equation 5. And this is the equation you get: 13 times current B plus 3 times current A plus 9 equals 0. And then from there, I went ahead and combined the reorganization of the second equation with our first equation up here. So I put in what we got for current 3 into the current 3 of equation 1, and then I went ahead and solved for what our new equation would be, and that gave us a really pretty one. Current A equals 2/3 of current B. So from there, we got two new equations, number 5 and number 6. From there, I just went ahead and combined those two equations. That took out variable A completely, and we were able to solve for current B, and we got that current B is 0.6 angstroms. And then from there, we went ahead and plugged in the 0.6 for our equation 6 and got that current A is 0.4 angstroms.
So now we have what current B equals and what current A equals. We know that to solve for voltage, you need I times R equals V, and that the total amount of change in voltage will depend on voltage A minus voltage B. So what's voltage for A? Voltage for A equals I times R. We just solved that IA equals 0.4 angstroms times 10 ohms. We only use the 10 ohms voltage because as charge is flowing this way, going up through A, it only goes through the 10 ohm resistor, it has not crossed the 5 ohms resistor yet at point A. So for V equals IR, this RA will just equal the 10. 0.4 angstroms times 10 gives us a 4 voltage loss. So from the battery, we have 9 volts going up here. After this resistor, we have lost 4 voltage. This is not total voltage, which is important to note. B is very similar. We have already solved in the previous equations that IB equals 0.6 angstroms. We use RB as 4 ohms because, again, the current is running through this way, goes through the 3 ohm resistor, and goes through the 4 ohm resistor. However, it has not crossed this resistor yet at all. Both currents do already cross the 3 ohm resistor together, so we only need to equate for these two resistance. 0.6 times 4 gives us a 2.4 voltage loss. Again, this is not total, this is just loss as the 9 voltage is passing through here. Change in voltage from VA minus VB is 4 volts minus 2.4, which gives us a round total of 1.6. To solve for which voltage has a higher, again, we have a 9 voltage battery that lost 4 voltages at point B to give us at point A, to give us a total of 5 volts at point A. Point B, the 9 voltage battery has lost 2.4 volts at point B to give us 6.6 total voltage. 6.6 minus 5 volts again gives us 1.6. Therefore, we have double-checked both ways that 1.6 is equal to our change in voltage total, and voltage B has a greater total voltage because it does lose less voltage up here via this resistance. Thank you for watching. Let us know and comment if you have any questions.
Bye-bye.